Hello and welcome back to my tech farm. My name is Igor and this is the second part of my Creality filament test. And I stopped there that what you see here is 40 hours of printing, all the test specimens and temperature towers. So if you didn't saw the first part, I definitely recommend you when I unboxed printing, analyzing the temperature towers. And in this part I will do the mechanical tests. Here you can see for the moment my printing settings for these materials, which are different from the generic material default settings in Cura. And the first mechanical test will be the layer adhesion. These are my test specimens for layer adhesion, and all I have to do first is to cut these supports designed by me for better bed adhesion. Smallest cross-section area is 4x4 mm and of course it is solid inside. ABS. And here there are test specimens after the layer adhesion test. Of course, don't forget a very big factor to this is the printing temperature. And here you can see the results summarized in the Excel table. And now let's move on to the tensile strength test, and these specimens are printed in horizontal position. In this test I'm expecting higher load, so I will use this chain hoist instead of my weight. And this is the result of this tensile test. And TPU was very interesting. Maybe I should separately create some TPU comparison video, because this is one of the most elastic TPU I tested so far. Next is the shear stress, and I have these test specimens in diameter of 5 mm. All I have to do is to clean this small support for better adhesion with the printing surface. And it will be a double-sided shear stress. And I redesigned this equipment a little bit. I added this bolt, and now it prevents that these two parts go away from each other. So it is now pure shear stress, double-sided, of the diameter of 5 mm. This is the result of the shear stress, and all test specimens broke on exactly 3 parts as they should, because this mechanism works fine. And here you can see in Excel table the result of this test. And before I start with the bending test, I noticed that, for example, this carbon filament is very light, so I will measure the weight of these test specimens, and since I know the dimensions, I can calculate the density. And to get more accurate, I will calculate two at once. 8.119 grams, 7.863, 8.205, 7.4, 6.711, 7.183. In this table you can see calculated densities, and if you want to convert kilogram per cubic meters to any other density unit, you can use this website. I built it a few months ago. In conversion tool you can find almost any combination of the mass and the volume. These are my test objects for the bending test, and the test specimen goes here. And I will use this piece of metal to bend it, and I will follow the load at 2 mm deformation and maybe the breaking load. TPU, but it already bends under the weight of this scale. That's it. This is the result of this bending test. I used only one test specimen because I have some plans with this one in the near future. And well, interesting that even the PLA didn't broke, only ABS broke completely. On TPU you can't see any deformations, and in this table you can see summarized results. Torque test. This test specimen has the diameter of 6 mm, and one end goes into the vise and the other goes into the wrench, and this torque meter can record the peak of one movement. So I will try to record the maximum torque and also the maybe number of the rotation before it fails. .8 so far. .7 so far, and it's broken. 1.2. 1.6, 1.2 after 90 degrees, 1.6, and now I can feel it's broken. PETG, 1.5 after 90 degrees, 1.7, and it's broken. 1.4 after 90 degrees, 1.7 was the peak. TPU, this is always interesting. No noticeable torque after 90 degrees. 0.3 now. 0.4 was the peak. And again TPU, nothing measurable on 90 degrees. 0.3. 0.4 ABS, 1.7 after 90 degrees, and it's broken. .7 after 90 degrees, and I can feel it's broken. So that was the peak too. Carbon fiber, 0.8 after 90 degrees, and it still resists 1.8, 1.8, 1.8 was the peak. 0.8 on 90 degrees, and it still resists 1.6, 1.6 was the peak. And this is the result of this torque test, and this PLA doesn't act like a regular PLA because usually it just broke, and look how many twists I could make even with the silk. And TPU, definitely I have to test TPUs in different video to compare some different brands, but I have to change the type of the test. If you have some suggestions, what would you like to see in that test, write me in the comment. ABS quite strong, but after 90 degrees it already broke, and carbon, it was very strong until, I don't know, maybe for 1.5 rotations. And here you can see the results in this Excel table. With this impact test, I want to see how brittle is the material. So from this list, probably the PLA is the most brittle. This means the distance between the zero position and the position after breaking the test specimen will be the smallest. So it is better if this distance is bigger. I have here 0.5 kilogram hammer. This is test specimen based on ISO impact test. You can see here the dimensions. And first I will record the zero position, and then the PLA, and the rest of the orders will be the same as with the previous experiments. The zero position. PLA. Silk. PETG. TPU, well, this will be an interesting one. Didn't even broke. ABS. Carbon fiber. And this is how they broke. So the PLA and silk quite brittle. Well, almost the PETG. The TPU didn't even broke. And this is ABS. Look how the color deformated on the breaking point. I hope it's visible. And this is carbon fiber. It's black even inside. Interesting. And now let's see the calculations. This is the scale, and this is the zero position where there are no test specimen. And this is after breaking the PLA. The distance from zero position is 21 millimeters. And this is after breaking the silk test specimen. Distance is 20 millimeters from the zero position. And surprising, this is PETG. So from these three, this is the most brittle material, but PETG should be more tough. And this is the TPU. I'm not sure if this even counts because TPU didn't even broke. And this is ABS, very tough material. So distance from the zero is 134.5 millimeters. And similar is the carbon, also very tough material. And you can see here the distance. And this is the calculation I use for calculating the energy using for break the test specimen. So this is the 0.5 kilogram hammer, this is the G acceleration constant, and this is the H distance from zero position, but in meters, and then I can get the joules, the breaking energy. And here you can see the results in Excel table. This is my temperature test in this oven. I will follow the temperature with this thermometer, which has a very small delay, but I know that approximately PLA will start the form at 50 degrees Celsius, because I want to record the temperature when they will start to deform. I have here M10 not as a small load. This thermometer has a small delay. I need better one, but it will do the job for now. PLA and silk deform between 50-55 degrees Celsius, PETG surprising only 60 degrees Celsius, TPU hard to see but approximately at 75 it starts with the deformation, ABS above 90. And carbon or nylon as a base material didn't deform at all in this test, and I stopped the experiment above 150 degrees Celsius. I stopped the experiment here because more than 160 degrees Celsius is inside. Quick analyze. Well, this I have to pick up with the spoon. Okay, this is very melted, and the PETG silk is, well, of course melted, but was this TPU, and also the ABS is soft. And look at this. Okay, it's a little bit soft. Let me try to. Oh, it's too hot yet. But it's quite hard. So almost 160 degrees Celsius. It didn't start the deformation, and it's quite hard. That's not the carbon fiber the reason, but the nylon as base material. And for the moment I will show you all results on one place. And now our final thoughts. Let's start with the PLA. It's not so easily printable like regular PLA. You saw I had some problems with overhang, but on mechanical test it performed quite good. Even in that impact test, PLA is usually brittle, but you saw in impact test or even in this twist test how many rotation I could make. So from mechanical aspect it's not bad. Unfortunately, one big disadvantage it has, and that's the heat deflection temperature. Similar is the silk, but probably this even wouldn't be included in these experiments if it wouldn't be sent by Creality. Maybe I didn't mention the PLA, PETG and ABS for my filaments, and silk, TPU and carbon was sent by Creality to extend this experiment. PETG. My first impression was when I saw the temperature tower that it is very nice, very printable material. But later I was a little bit disappointed in this material tests. First, it is the most brittle from the tested materials, but it should be more tough compared to the PLA. And also that heat deflection temperature just a little bit above the PLA, so approximately 60 degrees Celsius. That's not enough for the PETG. It should resist 70 or 75 degrees Celsius. TPU. Flexible filament. Oops. Okay. So one of the most interesting in this test, but definitely these test specimens are not good for this kind of test. I'm sure in very near future I will do some TPU comparison with different brands, and here I'm waiting your suggestions. What kind of experiment should I prepare there, because I cannot use this regular test. I have to test somehow the elasticity, maybe the hardness, so I'm waiting some suggestions from you. ABS. I was impressed with the layer adhesion, so that's one of the most important factors from this list for me, and it's quite good. I would like to see some comparison also in near future. I have some ESAN ABS Plus to see which is the best for the Voron printers for 3D printed parts. And carbon. Interesting, but I have to find, I have to experiment a little bit more with this to find a solution, what is the optimum settings to get a little bit better quality of the printing, little less stringing. And yes, it is very strong, but don't forget those carbon fibers are oriented in direction of the printing. So for example, in tensile strength it is much stronger, or in bending test. but it is not so strong in the layer adhesion test. Well, that would be it. So end of part 2. Thank you for watching and happy printing. So many broken plastic. 40 hours of printing just to break everything.